Hi, everybody, and welcome to the first plenary panel of IEEE Services 2020 on software service engineering and its ecosystem evolution. I'm Elena Ferrari, and I will be the panel moderator, and I'm also program co-chair of ICWS 2020. So I will say a few words about the panel, and then I will leave the floor to our panelists. So this is the outline of my brief presentation. I will start with the motivation. So why do we need such a panel at Services 2020? Then I will briefly mention which are the key issues in the area that the panelists will address. And finally, I will present our distinguished panelists. So why is it important to discuss about service-oriented software engineering now? Well, it's important because software services are now pervading all industry domains and markets, and as such, fulfilling constraints such as fast time to market or cost reduction or ability to quickly react to changes, or finally, security and privacy is today of paramount importance. And then there are some emerging application areas that are getting very popular and in which the development of software services is particularly challenging. So, for instance, I would like to mention smart societies and smart cities, cyber physical systems and human cyber physical systems, or think about intelligent resource management, or finally, think about intelligent medical applications that are so important in these days where we are all facing the coronavirus pandemic. So, these scenarios call for services with increasing capabilities and with advanced capabilities, such as the one you see in these slides. So self-awareness, self-adaptation, or auto-healing behavior, and also requiring low human intervention. So the point is, how can we manage service development and deployment in such a scenario, in a scenario of such a complexity? So as you all know, there are different software development and delivery practices and related ecosystems that we can use, and they are evolving over time. So for instance, the most recent ones leverage on machine learning and artificial intelligence. But the question is if they are enough. So some of the questions I would like to discuss with the panelists are the ones that you see in this slide. What are the strengths and weaknesses of existing approaches, as the one I mentioned you before? What the panelists view as the most important issues that need to be solved in the near future? And finally, what are some of the key use cases from industry and academic perspective? So we will discuss all these issues with our panelists, and we will also answer to the questions that we will get from the audience. So I'm very happy to have this set of distinguished panelists. They are all very well-known experts in the field, and all of them have done extensive and interesting research in the topic of the panel. So I don't have time to describe in details their biographies, but you can check them on the Congress webpage. So let just me briefly introduce all of them. So Dr. Dinesh Verma is the leader of the distributed AI team at IBM T.J. Watson Research Center. Our second panelist is Professor Sing Pen, who is the Deputy Dean of the School of Computer Science in Fudan University, China. Then we have Professor Xiao Sue from the College of Intelligence and Computing, Tianjin University, China. And last but not least, Professor Jia Zhang from the Southern Methodist University. She is very well known to our community, and she is the program co-chair of SEC 2020. So besides being excellent researchers, they are also very good, their expertise and background, it's also a very good mix, and so they can bring different perspectives to our panel. So the rest of the panel will be organized as follows. We will have a short presentation, 10 minutes, a short presentation from each panelist. And then after all the presentations, the panelists will be happy to answer to your question. You can, to answer to your question, sorry. You can ask your question to the Q&A panel. And even if we will answer to your questions only at the end of all the presentation, I encourage you to type your question at any time in the Q&A panel. We will collect them and answer at the end of in the second part of the panel. So that's it. Let's start with the presentation from the first panelist, Dr. Dinesh Verma. So Dinesh, the floor is yours.
Thank you so much, Elena. So let me go with my position on the software service engineering and its ecosystem evolution. As we know, there's so many ops. We have got DevOps, FinOps, etc. And I thought I will start the meeting first by sharing this comic, that cartoon that I found on the moving around on the WhatsApp channel. I don't know who the author is, someone at Cloud Guru, and I've taken it completely without approval and permissions. But I think the audience here would enjoy this particular comic, which shows how different things are ops. And I think the Triceratops probably reflects the real situation that we have in the industry, how we develop software engineering. What does happen, is that if you look at any of these things, and let's say we want to consider AI ops, we want to consider any other particular technology, not just in the operational and software engineering space, but almost in any other technology space, we see this cycle where technology goes up and down. And basically what happens is that someone creates a new technology, and the new technology is always great. It's our job, say in IBM research, to create new technology that will be useful for industry. The professors, my colleagues, other distinguished panelists, they always create new technology in different areas. And every time a new technology comes up, we basically end up, and the proponents of the technology, we end up saying that our technology is going to solve world hunger. Well, as it happens, world hunger is a difficult problem to solve. So we soon find out that there's some limitations in the new technology, no matter how good it is. And when the limitation happens, basically the next thing is, as I'm just say, okay, well, we tried it, didn't fail. Sometimes it happens. The new technology wasn't as promising. Let's go back to our bad old ways. And then some other new feature of the technology comes up, and we say, oh, well, yes, we really think this time we're going to solve world hunger. And we think that we again hype it up. And then we found out that, okay, there's another limitation of this, even of this new feature. And then everyone says that, okay, I'm not going to believe this technology is bad. And then some other new feature comes up, and we again go in that, okay, this third time it will solve world hunger. So this type of hype up and down is basically what happens every time. Sometimes people say that, like, if you look at the world of AI, people thought, okay, AI would solve everything and we'll have a lot of wonderful things. Then it didn't do, went through AI winter. Then someone said, oh, deep neural networks are going to solve all the problems. We had so much thing. And then that didn't quite work. So people are saying, oh, reinforcement learning will solve everything. And we have the same experience and the hype that happens all the time. And I know some other industries like Gartner has a different shape of the hype cycle. There are other curves and so on, different things. But essentially, we can see that as we try to publish papers, push a technology, we see these hypes, every technology go up and down. Now, what happens in the business side, which is all the people in IBM who work on trying to sell, make engagements, sell deals, and try to solve problems for the customer, they basically tell me that if you have to create a service, people don't really care about your hype. People don't care what your technology or what feature you're putting in. They only care about two things to get the service. One is, can you make the service to the client cheaper? Can you save cost in one way? And the second is, even if it is costing the same or a little bit more, is your service better than the existing service in some other way? If you want to use AI ops, is your AI ops going to make the service cheaper to operate? Or is your AI ops going to make some problems in the service run better? It will improve its reliability, it will improve its scalability, it will improve the amount of time that is spent trying to troubleshoot something slower or quicker. These are the things that matter. And when you look at the adoption of things in there, the adoption path there is following much more of a linear path or linear adoption in the real business. So what happens is we introduce a new technology, we have to go through the grind, and in the grind, when we try to get it through the service, etc., it gets adopted slowly. A new feature comes in, a new feature of technology introduced. We see a little bit of incremental jump, a little bit bigger adoption, a bigger steep things. But for the established business, again, it goes slowly. And then again, we try to introduce a new feature, a few more people sign on to the technology. So that's in a very contrast, a slowly gradual thing of the how the technology adoption goes in. And I want to share some real life experience that we had in IBM trying to create a service. And essentially the service what we had, we created a service on the cloud, or a cloud-based service, which essentially did network discovery. And it was effectively trying to discover what are the insights that can be gleaned from network packet captures that you put in there. When we started building it, AI ops was really at the hype. And basically we were told in no uncertain terms that if you really want to build this service, if you want anybody to ever pay attention to you and look at your service again, you have to use AI ops. You have to use AI in the service. So we tried very hard to put all kind of AI we can find, whether it was building the TensorFlow models, whether it was building a deep neural network, or whether it was just trying to use the existing scikit-learn and existing clustering techniques to throw that at the network problem. The stage two, which was our downward hype, was we found out that, okay, using all those AI-based technologies, trying to use AI to improve the operations, all the AI ops techniques actually didn't quite work. Maybe we were just clueless, maybe we just didn't know how to use AI properly. But whatever we found out is that if we just use our knowledge of how network protocols work and network domain knowledge, we could do things much better than doing AI. So that was a little bit of disappointment and a bummer that we couldn't quite get AI-based solutions to do better than what we can do with just AI ops wasn't really holding up to its hype. At the third stage, where we basically really wanted to use AI ops because we are in research and part of the IBM company, and if we didn't use AI, we would have been consigned to the dustbin of people working on old legacy technology as opposed to working on cool things. We tried a third push to try to use AI ops, and then we found out that, oh, if you have to use AI ops, combine some of this network domain system, add some of the new features, and you can get a much better AI-based solution than if you had a pure AI-based model. So we got a wonderful AI-based solution. AI ops was all the rage. We were in front of our colleagues in the and client-facing team. Our service was the model and epitome of how AI ops should be applied. And then the customer did the something which is the most dreaded of any research scientist. They actually thought we had something good and they tried to apply it in practice. And when they started to apply it in practice, we found out the next problem of AI ops, that our system worked very well for a couple of environments, assumptions that is there, but AI had learned to the system, and it would work very well in those cases where our operational assumptions of training the model was valid. But every time the operational conditions changed, it had to be retrained. And retraining was basically turning out to be a big problem, because essentially on the first three users of the service who had the AI training the same conditions that we trained our system on, they were very happy. But every fourth customer who will find that AI condition is different, they would basically come and scream at us that this stupid thing is not working. Your service is useless. So then we were kind of again back in a disappointment mode. Then finally we said, oh, okay, we can look at certain techniques, we can find out explainable AI methods, and that's what we are currently doing, looking at those techniques to improve our solution so that we will know when it is not going to work and be able to react better. So right now we are again on a like an upward trajectory of trying to get adoption. So our experience in that sense with this particular service and trying to use AI ops is very much that instead of going up and down on the cycles, we have got a steady train of people who are going to use this service gradually more and more. And even though we are sometimes overhyping and sometimes underhyping and falling down, the net, if you look at what the number of applications and number of deployments of the service is, that service deployment is increasing steadily. So at least my experience, bolstered by this and other examples, is that if we are a little careful with the hype, and we have to do some hype in order to get people to listen to us, but the real adoption of any of these technology, AI ops, etc., is gradual, and that gradually it would work and it will be adopted. That's my experience, that's my position, and now I'm going to yield the floor to Elena.
So thanks a lot, Dinesh, for sharing your experience. And let's go on with the second panelist. So Singh, the floor is yours.
Okay. Thanks for inviting me to join this panel. So I will talk some of my ideas and my understanding about the software service engineering and its ecosystem evolution. The background. So currently, software services are everywhere. So there's a universal demand for continuous delivery, quality assurance, and also cost reduction. So in emerging areas such as smart cities and cyber manufacturing, services are also popular. It's naturally that self adaptation and low human intervention are required. And the recent advances in AI provide new can push the service ecosystem developed ahead. So AI can be used in service engineering to support intelligent software development and operation. Let us look at the industry practice. We can see DevOps and also AI Ops, and also then the topic of this today's panel, that is the ecosystem naturally emerges. So for me, software and the service ecosystem does not is not created but naturally emerges. So today I will talk about two kinds of service ecosystems. The first one is the enterprise services ecosystem. We know now microservice architecture has been widely used in companies, and especially for internet companies like Alibaba in China. The Alibaba's e-commerce system has already 30,000 services, and the whole ecosystem of Alibaba has more than 100,000 services. From this picture, we can see the giant Alibaba has run many business around e-commerce and also other business. And this kind of enterprise service ecosystem can support not only the extension of new requirements of existing applications, but also can support the expansion of business domains. And at the same time, common business and technical capabilities continuously transferred into the infrastructure. In early stage, the infrastructure are more technical oriented, for example, the cloud infrastructure. But as the ecosystem grows, more and more business commonalities and the corresponding software implementation continuously transferred into the infrastructure. And so based on this kind of support, new business can be easily grow based on existing businesses and the technical infrastructure. The second kind of service ecosystem is the user-centric service ecosystem. this kind of ecosystem is popular in the so-called CPSS, that is cyber physical social systems. So in this kind of service ecosystem, the application is more user-centric and context-aware. For example, for each end user, we at one time, if you want to do something, the services around you can be combined in an on-demand way to serve and meet your requirements. So in this kind of service ecosystem, various kinds of resources and capabilities they are which are provisioned as services and integrated in an on-demand and opportunistic way to meet user requirements. So these two kinds of service ecosystem are different. For example, for enterprise service ecosystem, usually it has a clear boundary, but for user-centric service ecosystem, usually there is no definite boundary. And enterprise service systems consists of pure software services, but for user-centric service ecosystem, it includes different kinds of heterogeneous services. For example, some services are served by software, but some other may be served by physical devices. And also for enterprise service ecosystem, it provides different kinds of common applications for different users. But user-centric service ecosystem provide more personalized application for different users. And for enterprise service ecosystem, architecture design is still important. For example, as I mentioned just now, microservice architecture is popularly used. So architecture design very important for enterprise service ecosystem. But the user-centric service ecosystem, we seldom mention architecture design. We often mention service mashup. And for enterprise service ecosystem, I mentioned just now, most of them maybe microservice architecture. These kind of systems are usually deployed and run on cloud. So it's easy for them for achieve very good scalability. But for user-centric service ecosystem, the scalability is limited due to physical constraints. Because, for example, if there are some service provided by a coffee machine, if you want to scale to 10 coffee machines, it's not so easy due to the physical constraints. And for enterprise service ecosystem, it also can have some auto, that is online to offline service integration, but this kind of integration is predefined and applied. But for user-centric service ecosystem, it's very popular that opportunistic integration of different kinds of resources, for example, cyber, physical, and social service resources. But at the same time, there are also some commonality between these two kinds of service ecosystem. For example, both of them are software-defined, include software-defined virtualization of different kind of resources, and also both of them have service discovery and integration. Also, both of them are required to be highly adaptive, and to support continuous evolution. And also, service governance are required for both the two kinds of service ecosystems. And for enterprise service ecosystem, for me, I think the challenges come from two sides. One is from the development and maintenance. The other is from AROps. From the development and the maintenance aspect, this kind of enterprise services ecosystem can be very big. Just I mentioned just now, the Alibaba service ecosystem maybe can include more than 10,000 services. So this kind of ecosystem is too complex. So there's there no nobody can have a global view about this kind of ecosystem. And also it's popular that the developers reinvent the wheel, and also the architecture of the ecosystem will degrade. From the aspect of AROps, according to our understanding of the current industry practice, AROps is still in its infant stage. There are many challenges. For example, this kind of service ecosystem produces very huge data. For For example, for some very big microservice systems, it can produce billions of traces per day. Even sampling of the traces is a challenge. How to sampling? I often discuss this kind of topic with companies, engineers. Sampling, even sampling itself is very challenging because so many traces. So we need to use sampling. But how to sampling? So if the sampling is not no, that does not work well, maybe you will miss some very important trace. That is that is very important for example for your diagnosis of some problems. And also intelligent decisions are made automatically by your AIOps platform is not well trusted. According to our experience, for industry engineers, they will manually check the recommendations of the AIOps and then make the decision. That means that the final decision is made by the human, not by the AIOps platform. Also, for example, for microservice observability is very important for the AIOps because it can allow us to understand how the runtime behaviors of the microservice system, also help us to diagnose different kinds of problems. To have a good observability, we need to combine log, traces, and the metrics. How to combine these three different kinds of information is also very challenging. For user-centric service ecosystem, I think it has quite different challenges. First, because this kind of ecosystem involves physical resources, we want to make it to be wrapped as services. So it's very challenging for the digitalization and the service wrapping of some physical resources. For example, we want to have some kind of software-defined coffee machine. That means that we can use API to interact with the coffee machine. And also service registration and discovery in this kind of open environment is very challenging. Also, we have heterogeneous service interaction, different from the enterprise service ecosystem. The services in user-centric service ecosystem are heterogeneous and also different. How to make different services to know each other, to talk with each other is very. And also end user programs, user-centric service ecosystem. Just now the application is more personal, and maybe we need end user to be involved in the program. Maybe they can program or customer personalize the application for themselves. And also trust and value exchange, because I mentioned just now, this kind of ecosystem is run in an open environment. Maybe for example, some the physical resources belong to different people, belong to different organizations, but in the given scenario, we need to combine them together. So how we can trust each other, how we can establish some kinds of mechanism for the value exchange, I think is also a challenge. Okay, that is all my understanding and thought about the topic of this today's panel. Thank you.
So thanks a lot, Sean, for your, view on the panel topic. So let's move to our third speaker. So Xiao, the floor is yours. You can share your screen with the presentation.
Hello, everyone. I'm Xu Xiu from Tianjin University, and the topic of my report is Service Ecosystem, a Lens of Smart Society. My report includes three parts: research motivations, analysis framework, and our progress. Today, the emergence of intelligent technologies are promoting the evolution of human society. The human society is like a container in which these intelligent technologies continue to perform combinations and fusions to construct various intelligent applications. As shown in this figure, there are some typical intelligent applications such as smart facility management, smart garbage collection, and smart transportation. As the bridge between intelligent elements and end users, service give a unified description logic to everything in smart society. In fact, smart service is becoming a new operating rules for human society, so call it smart society. It's obvious that service plays a very important role in the smart society, making the collaboration and integration of all kinds of elements connected together, as shown in this figure, such as including smart energy networks, smart government, and smart health networks. The entire society has evolved to be an ecosystem. This evolution is driven by technological innovation with energy and vitality beyond imagination. It can be seen that service ecosystem is the intersection of business, technology, and service computing. It has the characteristics of complex adaptive systems such as open, dynamic, evolving, and autonomous. These characteristics bring huge challenges to its operation and optimization management. On the one hand, smart services have duality characteristics such as the security of personal privacy, defects of machine intelligence, and other potential risks. On the other hand, the relationships between smart services magnifies those potential risks. We only see the tree but the forest. So we need a new discipline that can reveal the full picture and the evolutionary laws of a smart society. That's a service ecosystem. We focus on two questions. The first one, what's the laws behind the evolution phenomena of service ecosystem? The second one is how to identify the expansion boundary of service ecosystem in human society. In order to answer the two questions, we propose our analysis framework. As shown in this figure, we give the operation logic of service ecosystem. It includes three networks: service network, social network, and value network. They are connected to each other. The idea is from as always structure is also like a triangle. As we all know, natural ecosystem includes three necessary elements. It's environment, species, and circulation mechanism. So service ecosystem also consists of three networks. Social network is equivalent to external environment. They are an important factor influencing the implementation of smart services, including population, laws, culture, customers, and industries. Service network equivalent to biological species, where various services coexist in cyberspace, including human intelligence services, machine intelligence services, and human-machine coordination services. Value network equivalent to circulation mechanism. As a media, the value cycle connects service requesters, service providers, and service operators. The dynamic operation of service ecosystem, it consists of three legs. Everything as a service, service as a commodity, value as a coordinator, we are familiar with everything as a service. So let's focus on the other two. Service as a commodity. The service matching between provision and demand can be finished in a service marketplace, just like a commodity transaction. In the end, such a value circulation can be formed, including value creation, realization, and distribution. Value as a coordinator, it means value network as the connector between service network and social network. It can promote the adjustment and evolution of social work and service network. Based on the description logic, we proposed our analysis framework. There are three steps. The first step, measurement and evaluation. The second step, modeling and analysis. The third step, emission and induction. Now I will give the details. The first step. This step constructs a health evaluation index system or a service system from three perspectives. Firstly, the service ecosystem is similar a natural ecosystem, so it has some ecological characters. Secondly, in service ecosystem, service providers use value-added services to meet the needs of users. So it has some economic characteristics. In addition, there are complex competition and collaboration relationships between services in service ecosystem. So it has the characteristics of complex network. The second step, analysis of service ecosystem. In order to analyze the evolution loss of service ecosystem, our research is carried out from three levels: macro behavior model, medium structure model, and macro mechanism model. Multi-agent system is used to study the adaptive behavior of services. Complex network theory is used to study the emergent structure, and the system dynamics theory is used to study the internal mechanism of system evolution. The third step, intervention of service ecosystem. Individuals in service ecosystem are autonomous and adaptive, so the centralized control methods will no longer be suitable for the optimization of service ecosystem. Then the method based on induction will be an effective means. Our research from the two perspectives to design the induction mechanism that's existing services and new services. The third part, I will explain our current progress. It's our platform. As we all know, service ecosystem is a complex system. So it's difficult to find an appropriate research tool to study its evolution. Computational experiments provide new and more effective control theories and methods for research on complex systems, including its analysis, design, management, control, and other synthesis problems. So it's our new published book. It's about computational experiment method for complex systems. It's available on the following website. Welcome everyone to give some valuable suggestions for this work. Based on the computational experiment platform, we have built a simulation environment for the evolution of service ecosystem. This helps us to evaluate the performance of all kinds of interventions. Now, by using the simulation environment, our work have covered the following areas, including operation diagram, evaluation, analysis, intervention, and application cases. This concludes my report. Thank you for your attention.
So thanks a lot, and let's move to our last speaker. So Gia, please share your presentation. Thank you.
Thank you very much, Elena, for organizing this very important panel on this very important topic in services computing area. We have already heard our other distinguished panelists talk about the various kinds of state-of-the-art techniques and the challenges from different angles. So now I'm going to talk from a slightly different angle about like the service, the scientific service discovery and recommendation based on the knowledge network. So similar to the normal like software services, we know that the services computing technique has been driven the software engineering into the third generation, that is the service-oriented software engineering. The techniques has already allowed people to move from the craft shop-based software design development into the assembly line-based software engineering process, so that from the service ecosystem, people can reuse and compose existing software services, and so that they don't have to build everything from scratch. And at the same time, for their developed software system, they can push back and publish into the service ecosystem so that other people can start to reuse. So then in order to make this service ecosystem working, especially in scientific field, the scientific field will more focus on the big data analytics software, the services. That's what we're talking about. And similarly, we're applying various kinds of techniques in the field, like to facilitate the scientific service discovery and recommendation, including the syntax-based approach and the semantics-based approach and the historical usage-based approach. And in recent years, there's another direction. People start to use the knowledge network-based approach to help people to identify data analytics software services. So a little bit history about like the knowledge network, and the term sometimes people also call it the knowledge graph. It was originally started from a Google project called Knowledge Graph, and in 2014 the name was changed to Knowledge Vault, according to the formal announcement by May 2020. Google Knowledge Vault has already accumulated 500 million facts on about like 5 billion entities. So as you can see on the right-hand side, and if you type in Newton's name, in addition to a list of links you can get from the Google, then you can also get a number of information summarized by Google, supported by this knowledge graph, based on what other people may be interested to know, and then what Google think the user may be interested to know. But then if you type in hurricane in Google, you will not really get interested information for a researcher, because from an earth scientist perspective, what they are interested in is which data set should I study, and how to process this data set, and how and what did others do on this data set. So this kind of information then will help people to reach their goal, because from a scientist perspective, they want to know how to best use the data tool set and methodologies and data analytics software services, and to answer some hypotheses. So based on the knowledge graph supported by Google, which only contains the entities as people, place, and things, you cannot really answer such questions. So in order to answer these questions that are interested to scientists, then we need to build we need to build a scientific knowledge graph. So this is to briefly just like a showcase like what we mean scientific knowledge graph. You can see that, and then while people know that like we have the papers and we have users, and such information we should we call to extract some of the very important information from the papers, from scientific publications out as first-class citizens, such as data sets like variables and algorithm, tools, etc. If we extract them as the out as first-class citizen and build the scientific knowledge graph, then in addition to the regular research like discovery, service discovery, and the recommendation methods, we can apply some topology-based network analysis. So for example, here, by analyzing the two subtrees routed by these two users, then we can, by analyzing these two trees, we can see the similarity between these two subtrees. Then we can recommend some of the algorithm to another user. So in this way, if we build a scientific knowledge graph and build the service recommendation engine on top of this, we can provide more fine-grained the recommendation. And at the same time, we can realize optimization and parallelism on real-time computation. So as we mentioned, how to extract such information, we can extract such information from the scientific publication. So, and then we found that like how to build this scientific knowledge graph based on this by analyzing the scientific publication has a lot of challenges. Here are some of them. So then as we see here, if we have some project and we're trying to train the machine to read scientific paper, we can see that you can extract such information from the scientific paper. However, this is the reality is that like although we have a DOI digital object identifier, unique one for everybody to track like a data set. However, in reality, a lot of scientific papers in earth science, for example, they do not really like mention the data set name, but this is also very important for scientists to know. And then, but we, from a series of workshops we conducted with data scientists, we found that there's no problem for human users to understand which data set this paper is about. Even though the paper did not mention the data set name, we found that all of the data sets, because they must be gathered data from some satellite, from some sensors, and contain some of the variables. So there's some work my team did earlier. So we just like apply the neural network techniques, and we model different, if we can identify the platforms and the instruments and the variables, and then we consider this as kind of a different kind of like the sentences like in natural language processing. And when we train the machine, then we can guess which kind of data set this paper is about. So with these two simple use cases, what I want to say is that I want to set the ball rolling. And so what I try to say is that right now for scientific software service discovery and recommendation, there's a long way to go, and there's a big room for everyone in the community to jump in and contribute more. And specifically, we have been organizing this actually workshop on knowledge network. And then we hope that we want to call and advocate the importance of applying knowledge network techniques to facilitate software service discovery, recommendation, and composition. So that's my presentation. Thank you.
So thanks a lot, Gia. And now we are ready to get questions from the audience. So I have a first question from Barbara. The question is related to user-centric services. And so the question is the following. It seems that the user-centric services are one of the most popular scenarios. How can we manage privacy and security issues in their development? So I guess that this question is for Singh and Xiao, but also the other panelists can answer as well. So please, if you would like to answer.
Okay. Okay, so can you hear me?
Yes.
Okay, so I think maybe I have no good answers for this question. First, I'm not an expert on privacy and security. Second is that I think we are still on the early stage. That means that the current focus is to make things happen. That means that we want to develop enabling technologies to make the user-centric service ecosystem to be a reality. For example, we want to develop techniques to use a software-defined technology to define, for example, the software-defined coffee machine that to transfer coffee machine into a service into some services that we can interact, and also provide some kinds of user programming technology to allow end user to define their application, something like this. So I think we are still in the early stage. So our focus now is to develop enabling technology to make things happen. Okay, that's my answer. Thank you.
Sorry, Xiao, would you like to add something to, or the other panelists would like to add some comments? So I have a question for the panelists. It's a general question. So it's true that we are often learning by mistakes rather than by successes. So my question is kind of a philosophical question. So what's something you believed early in your career about software service engineering, and now you know that is completely wrong, and what we can learn from this? So I like to see not only the success stories, but also the failures that make you able to learn something. So is there a technology or, you know, a development practice that you believe in the past it was solving all the issues, and then you realize that it was wrong?
Okay.
Yes,
You
please.
want me to go first, Elena? Is that okay? Okay. So when I first came out of college, I had come out with looking at all the best practices of software development, service development. So I always believe that if you have to build a software algorithm, you implement it using the most efficient manner possible. You did it in the most elegant manner possible. Try to promote code reuse, etc. And the thing that I essentially realized that when it comes to making successful services delivery is that the technical technical excellence in the sense that following the best practices, doing the right, making it the most optimal one, structure it right well, etc., is only one of several factors that go to making a successful service. And that depending on what you have got, the amount of the time you have to deliver something, the amount of appeal a service has in the business or commercial context, the amount of whether you or not you are solving the problem that is immediately of urgence or important to the thing being done, tend to be also factors that sometimes have more defining role. So essentially, the biggest lesson I would say I learned is that in addition to just focusing on the technical aspects of developing a service, the non-technical aspects, the business need, the time to delivery, getting the even dirty but functional code up and operational, those often have a big say or big impact on getting a successful service started. So that at least I found that very surprising, at least initially.
Elena, can I say something? Since I'm in academia, so we've been teaching students how to do software engineering. We have a whole course of software engineering for many years, but in recent years, because of the software service engineering, then we have to teach students that this cause fundamental mind changes from two perspectives. So number one is instead of you have all of this start to do requirements engineering and software design development, now the first step you need to think about the service-oriented architecture. You need to think about what kind of existing software services may fulfill or partly fulfill some of your requirements. So your design becomes how to leverage SOA and try to utilize these existing services as components to build your new system. And this number one. Number two, the main change is that now instead of in the traditional software engineering process and you deliver something and you maintain it and you're done, you move to the next project. Now you build a software as a service, then you need to think of anybody in the world, they may access it, and also anybody may use it in a different way and with different requirements, and you want to deliver it as a utility service. So you need to think of how to really deliver your software as a service instead of just a software. So I would like to mention those two main changes. Elena, we cannot hear you.
Yes. Okay. Thanks, Gia. Is anybody else of the panelists that Sin, please.
Yeah, I think one lesson for me is that we need to we need to carefully learn what the industry the system in industry looks like instead of imagine about it. Many years ago, when we do something, maybe we imagine, for example, service-oriented architecture should look like this. So we imagine, we assume that there are a lot of services registered there. Then we can look up, we can find the services, and then we can compose them. But we do not care what the industry service system looks like. We don't care what the real scenarios for these kind of applications. But now I think we need to learn from the industry. For example, the microservice architecture now is very popular. Also, we have a team on microservice and also AROps. So for this kind of research, I think we can only have a very correct or good understanding about this topic based on the industry experience. But the industry, they themselves have successfully developed and run these kind of systems for their real applications for their business. And also we need to try to build the real, for example, for the end user user-centric service ecosystem. I think we need to build real user scenarios. For example, because this kind of scenario are around every one of us. So we also have a team on the user-centric this kind of service technology. So we can build different kinds of real scenarios around us. We can only have a good understanding for this kind of technologies based on this kind of experience from industry or from real scenarios. For example, even because service is some kind of runtime entities. For example, for AROps, it's about a runtime operation. I think only the companies have the data about this kind of the operation or runtime operation of service systems. So if we do not collaborate with the companies, we cannot get real data about ops. We cannot understand the scenarios of ops, something like this. Okay, thank you.
So any other comment? Or we have another question from the audience, from Eddie. The question is for Xiao, but feel free to answer also the other panelists can jump and answer this question. So the question is related to how to incorporate cooperation concepts in the analysis and modeling of the smart services ecosystem. So,
okay, I can have a try to answer this question. I think service ecosystem is not a question only in the field of software development. As shown in my report, service ecosystem is a social technical system. So the evolution of service ecosystem is a multidisciplinary questions. And it has the characteristics of complex systems such as emergence, burst, and feedback cycle. So the evolution of service ecosystem it's hard for us to answer clearly, good or not. Especially the interaction between machine intelligent services and human intelligent services. This is the motivation for our research. In my opinion, service ecosystem is like a lens or a research tool to help us to analyze the evolution of a smart society. And in our analysis framework, the in cooperation is considered in social network and service network. In social network, the service providers, service operators, and service consumers are modeled as every agent, and those agents are autonomous. They can cooperate with each other, and those cooperation relationships are mapped in the service network, and it's like service composition and service convergence and other similar phenomena. But the cooperation phenomena is very difficult. We now this is the research focus of our team. That's my answer.
Okay, any other comment? So Gia, maybe knowledge graphs can also help, no, in solving these cooperation issues, isn't it?
Yeah, I think so. I think that's a very good angle. And as a matter of fact, we have my collaborator and I, we have also been building the software social network based on like a knowledge network. Yeah, so I think that's probably like a can also address from some of the angles.
Can I ask a follow-up question of clarification? The Axelrod model of cooperative theory was designed more to model human beings and how people interact with each other. And the software services that we create tend to have much more simplified behavior, whereas these cooperation models like that of Axelrod model much more complex type of cooperation. Now, there is a trade-off between the complexity of modeling complex way of cooperation and of that of simple services. Like when you design a enterprise microservice architecture, that's kind of often very rigorous, and the flexibility is limited. I mean, it's there, but it is limited. So for the services evolution, I would just be interested in Professor Xiao's and everyone's view on where do they see the boundary shifting between rigid structure between distributed services, which are much more analyzable by CS techniques, versus flexible interconnections and much more human-like social services, in which case we'll have to resort to Axelrod or other social sciences or economics or sociology techniques for modeling them.
Okay, any other comments or?
Very quick.
Yes, please.
Yeah, I really like what Dinesh just mentioned, and I think, as a matter of fact, the more research I've been doing in this area, the more belief I have is that the software service engineering, as a matter of fact, is getting more like a multidisciplinary field. Yeah, we do need more than just software engineering researchers, but also researchers from different like domains, of course, but also like social science and psychological science and other sciences to join. Yes.
So thank you. So there is another question from the audience. The question is from Andrei. And the question is, what are your predictions for AI ops? How is going to shape service development in the short term and in the midterm from both an academic and industrial perspective? So we have both people coming from the academy and people coming from industry, so we are in the right position to answer to this question. So who want to go first? Okay, Sin, please.
I mentioned just now, AIOps is still in its early stage, but at the same time, I think it's the right direction. So there's a long way to go. According to my understanding of the current industry practice, AIOps can at the basis of AIOps is data. First, you need to connect a lot of data. For example, logging, tracing. I see in some very big companies they have invest a lot on the infrastructure, because you need to have very good infrastructure to connect the very large volumes of log and also try to assemble them into traces and also collect different kind of metrics. So you need to establish this kind of big data infrastructure. That is the first step. Then, based on this kind of big data, you can first try some techniques like visualization. So you can develop some tools for visualization to help the developers to examine the logs, the traces, to help them, for example, to diagnose the problems, the root cause of the problem, something like this. And the second step, you can try some automatic recommendation. I know in some companies, for example, when a runtime issue is raised, the developers the system can push a recommendation to the developer, for example, to get 3 candidate root causes for this problem. Then, based on the recommendation, maybe the developer can spend a short time, for example, several minutes, to verify the results and confirm the real root cause. So I think this kind of technique is mature enough to be used. Actually, in our collaboration with companies, we are doing this kind of research. So I think this kind of AIOps techniques is mature enough to be used. But the basic I mentioned just now, is a very good big data infrastructure, and I think AIOps can do more. But there's a long way to go. So my suggestion that first to establish a big data infrastructure. Second, try visualization to assist the developers. And second, then you can try some recommendation. That means that still the human developers will make the final decision about the localization of the problems, also about the scalability decisions, but the AIOps system can provide some suggestion. Okay, that is my feedback.
Okay, any other comment?
Okay, so let me offer my perspective. That's okay. I think, just by relying on my experience with at least a flavor of AI ops I'm doing, my guess is that in 1 year, the application of AI ops in practice would be to in very limited narrow domains. What happens is that the people or the administrators who are running the different type of services in business and commercial environment, they generally they are usually good at their job. They know how to run a service, they know how to troubleshoot it. And let's say the general 80% of the problems are solved. Now, a few problems still remain. By no means is all the problems remain, and they do have to go through a lot of these operations and procedures. And the first thing there would be that if you look at where AI ops is really good at, or where AI is good at, when there's too much data and you can't really fit a nice model that is known to the person who is running the service, that's where AI could be applied and found. And initially, since there will be a few niche areas which have to be make the connection, and in 1 year you'll see AI ops only being used for those particular niche areas. Then as those gets adopted in that area, the benefit of using AI, which is basically you need less modeling, you need less expert people to have the model, or their system can automatically build model within constraints, will get adopted. So in 5 years, I would say AI ops would be basically be the dominant methodology. People will say, hey, how come I didn't really use it? Now the AI here would be more general than AI as a deep neural network or AI as a learning algorithm. AI, I would say, expand to be broader general analytics and modeling applied. And then after that, in 10 years, it will be a business as usual. We'll no longer be considering AI ops as a new technology. In 10 years, AI ops will be as mundane to us as, writing a shell script.
So we have another question from Lily Xu from the audience that is related to this last question. What's your opinion about cloud AI ops services? So it's a question for all the panelists. So who would like to answer to this question?
Okay, so well, I guess I have the benefit of better connection.
Yes.
So here's my thing. Cloud is a wonderful technology which is overhyped. AI ops is a wonderful technology, it's overhyped. Cloud AI services are technology that are hyped square, but there is a nugget of value. Cloud has a lot of value, and there are certain aspects of cloud computing that are extremely valuable for use within all services. And there are certain aspects of AI ops services that can really do a job better than any other current approach of running or managing or operating a service. So there are niche areas where cloud AI ops services are really useful. And there are a lot of areas where cloud AI ops services are just two hype word combines, with one of them maybe providing some value. So as long as you're talking about cloud AI ops in a narrow specific context, it could be very useful. But in many other contexts, it would be pretty useless.
Okay, thanks a lot, Dinesh. Any other comment on this question? So I have a last quick question for you, because we have 7 minutes left. So what is the take-home message we can leave to our audience out of our discussions and all the presentation? Just a brief comment from all the panelists to conclude. So, Gia, would you like to go first now?
Okay. I would say that while we have a very bright and very prosperous community on services computing, so for many years, since 2004, so I would like to call for more contributions and attention for the applying services computing on scientific the services, be more specific, big data analytics. So yeah, that's what I would like to say.
So Singh, do you have a take-home message for the audience?
Yeah, so my suggestion that for service ecosystem, I recommend that we need to try our best to collaborate with. For academic people, so my suggestion is that try to collaborate with the industry people because they have real service ecosystems, they have the real data, they have the real scenarios, and then they have the real problems. Okay, that is my remark. Thank you.
Thank you. Xiao, please.
Yeah, I'm honored to have the opportunity to share my report. My focus is not AI OPS, but I'm interested how service ecosystem change human society, especially machine intelligent services. Its effect on our lives. That's my research interest. I think it may be more interesting than AI OPS. That's all.
Thank you. So Dinesh?
I think my summary is only one thing. I learned a lot from the different ecosystem and from the different panelists talk. My main comment from industry perspective would be simply, there are a lot of servicing technology, a lot of new approaches that are coming. Each approach delivers value in certain specific context, certain specific certain specific, and when certain conditions are satisfied. And when we are trying to build services and manage them, we basically have to make sure that the services for applying, the conditions for applying the technology are valid. And by making sure that we are applying the right thing when the conditions are right, as opposed to just trying to follow a hype word that let's do everything in cloud or everything using AI ops or whatever the current flavor is, we will succeed. When we try to follow something just because something is AI or something is cloud or whatever the flavor of the month is, then we fail. That's my very simple lesson or summary of how services engineering should be done.
So thanks a lot, Dinesh. And so we are running out of time. I just want to thank again the panelists for their very interesting presentation and discussion. I also learned a lot from the discussion. I would like also to thank the audience, even if it's a virtual panel. And so as panelists, we feel a little bit alone because we cannot see the audience. We got a lot of interesting questions and comments. So thanks very much for joining the panel. And that's it. Enjoy the rest of the Congress and goodbye. And thanks again very much.